The story Americans are told about technology is clean, efficient, and almost weightless. Software eats the world. Intelligence becomes artificial. Energy turns green. Progress appears to move faster while using less. But that story leaves something out. Every technological leap, no matter how digital it looks on the surface, rests on physical materials underneath. Wires, contacts, conductors, metals that do not scale with ambition, but with geology. And one of those metals sits quietly inside nearly every system now being called strategic: silver. This is not a story about innovation. It is a story about constraint, about what happens when a country builds its future on technologies that all depend on the same scarce input, without ever planning for its supply. The industrial boom in silver is already underway, not announced, not debated, but embedded into factories, power grids, data centers, and defense systems faster than most people realize. By the time it shows up clearly in price, the decisions have already been made. The factory is already built, the infrastructure already committed. This is not a story about opportunity. It is a story about commitment without escape. The modern technology narrative suggests we are moving away from materials, toward intelligence, toward software, toward abstraction. In reality, we are moving deeper into material dependence. Silver is not visible in product launches or keynote speeches. No company advertises how much silver it uses. No politician campaigns on securing silver supply. But remove it, and the systems stop working. Solar panels rely on silver paste to collect and transfer electricity. It sits in the grid lines, thin but essential. Engineers have spent years trying to reduce the amount per panel, and they have succeeded, marginally. But solar deployment has grown faster than efficiency gains. So even as silver use per panel falls, total silver demand rises. More panels, more capacity, more grid expansion, more storage, more transmission. The result is a paradox the clean energy narrative rarely addresses. Green energy is not less material intensive. It is differently material intensive. And silver sits at the center of that difference. Electric vehicles tell a similar story. They are marketed as battery-powered machines, but batteries are only part of the system. EVs rely on complex electrical architectures, power electronics, inverters, charging systems, safety controls. All of them require high conductivity, reliability, and resistance to heat. Silver appears everywhere those requirements intersect. As EV adoption scales from early adopters to infrastructure, silver demand scales with it. Not as a luxury input, but as a performance requirement. Substituting away from silver reduces efficiency and increases failure rates. At scale, those trade-offs become unacceptable. Then there are data centers. Artificial intelligence is not abstract. It runs on servers. Those servers run on power. That power flows through miles of wiring, contacts, switches, and cooling systems. Each layer introduces resistance. Each inefficiency compounds. Silver reduces those losses. As AI workloads grow, data centers are being built larger, denser, and more power-hungry. This is not a cyclical demand. It is a structural expansion driven by national competitiveness, corporate advantage, and strategic ambition. Once built, these facilities do not scale back. They lock in demand. Robotics pushes the dependency even further. Humanoid robots like Tesla's Optimus are often framed as future products, but industrial automation is already here. Sensors, actuators, motors, control systems. Each one relies on precise electrical performance. Silver enables reliability. Reliability enables automation. Automation enables productivity. Remove silver, and the machine age stutters. Then there is the part of the story that rarely gets discussed openly. Military and communications infrastructure, radar systems, missile guidance, secure communications, satellites, 5G networks. These are not consumer choices. They are national security requirements, and they use silver extensively. When governments need these systems, price is secondary. Availability is everything. This is where the industrial silver boom becomes a strategic issue rather than a market trend. The United States wants technological leadership, energy independence, military superiority, supply chain resilience. All of those goals quietly increase silver demand. And yet, the supply chain for silver remains global, constrained, and vulnerable. This is the collision point. Efficiency improvements cannot eliminate silver. They only slow consumption per unit. But when deployment accelerates, total demand still rises. Technology does not reduce material dependence, it redistributes it. And redistribution at scale creates bottlenecks. This is why the industrial silver boom feels less like a trend and more like a trap. Not because the technologies are flawed, but because they are successful. Because they are being adopted faster than the materials that support them can be secured. This is not a tech boom. It is a metal war hidden inside a tech boom. Nations compete for leadership, but leadership runs on inputs. and inputs obey physical limits. Silver is one of those limits. And once an economy commits itself to systems that depend on it, there is no painless way to unwind that commitment. What makes this moment especially uncomfortable is that none of this demand is discretionary. Solar power is not being expanded because it is fashionable. It is being expanded because energy security has become a strategic priority. Grid resilience, domestic generation, reduced exposure to external shocks. Once those objectives are set, material requirements follow whether markets approve or not. Electric vehicles are not just consumer products, they are policy outcomes. Emissions targets, industrial subsidies, and supply chain realignment have locked them into long-term planning. Factories are already built, platforms already designed. The silver required is already accounted for, even if the metal itself is not yet secured. Artificial intelligence is even more revealing. AI is not a gadget, it is infrastructure. Governments want it for defense, corporations want it for productivity, nations want it for competitiveness. Data centers are being approved, financed, and constructed years in advance. Their power requirements are fixed, their material inputs are non-negotiable. Silver is embedded at every level. Once these systems exist, demand becomes inertial. It does not respond quickly to price, it does not pause politely during downturns, it persists. This is where the concept of substitution fails. Yes, engineers can reduce silver content, they can redesign contacts, they can optimize circuits, and they will. They always do. But substitution is not elimination, it is compromise. And in systems where reliability, safety, and performance matter, compromise has limits, especially in military, aerospace, and critical infrastructure. These sectors do not optimize for lowest material cost, they optimize for failure avoidance. Silver survives those optimization processes because it performs. This is why industrial demand does not fade when prices rise. It adapts, it absorbs, it passes costs through. The competition, then, is not between silver and alternatives. It is between users competing for the same finite supply, and that competition is intensifying. This is where the narrative intersects with America First. The United States wants to reshore manufacturing, secure energy independence, dominate AI, and maintain military superiority. Each of those goals increases domestic silver consumption. But domestic silver production covers only a fraction of that demand. The rest comes from a fragile global supply chain. Mexico, Peru, Latin America more broadly. Regions facing political volatility, environmental pressure, and social resistance to mining expansion. This creates a strategic vulnerability that cannot be solved with rhetoric. You cannot onshore silver supply overnight. You cannot accelerate geology. You cannot bypass permitting timelines with executive orders. Meanwhile, the machines keep coming online. This is why the industrial silver boom is not simply a story of growth. It is a story of exposure, of discovering too late which inputs your future depends on. Every new solar installation, every EV factory, every data center, every autonomous system quietly tightens the market, not because silver is rare in absolute terms, but because its availability at scale is limited. This is the kind of constraint modern economies are least prepared for, not cyclical, not financial, but physical. And physical constraints do not respond to confidence, they respond to price. As demand locks in and supply struggles to respond, the market does the only thing it can. It reprices the metal upward until balance is restored, not at a level people prefer, but at a level that forces adaptation. This is why the industrial silver boom feels inevitable rather than exciting. It is not driven by optimism, it is driven by necessity. The technologies that define the next decade are already chosen. Their material needs are already embedded. The only open question is how the system absorbs that reality. Silver is not benefiting from hype. It is being pulled forward by an economy that has already committed itself to using more of it than it can comfortably supply. And once that commitment is made, there is no easy way back.